today the topic of the presentation is how you can build new protocols and products using the concept of recipes. So we're going to use this concept to explain that in an easier way for developers. So a bit of an introduction by myself. So my name is Jean. I'm the lead smart contract developer at LUKSO, and I'm also the author of All About Solidity, an article series on Medium to teach people how to write a smart contract and the inner details of a Solidity language. And I'm really passionate by smart contracts and this technology and how these can be used really to build new application and really new form of business models. So here's an overview of what we are going to look at in this presentation. So first, before to dive into LUKSO, we are going to look at the concept of what is a recipe, how it applies to blockchain, and why is it relevant actually to Web3 and blockchain. And then we will narrow it down to LUKSO and the LSPs, and we will look at, so we'll start from simple recipes with just plain metadata examples, to LSP1. You probably noticed on the previous presentation with LSP1 there is a lot of things that can be done. And then we'll look at more advanced combination, how you can combine the standards together in a more complex way. Okay, so yeah, first of all, a little disclaimer. In this presentation, you are going to see a lot of illustration, a lot of memes. I think at LUKSO there's three things that we love really much. We love our community, we love what we are building, but we love Figma and Miro. We have 1 terabyte literally of diagrams. So you're going to see a lot of these. So yeah, and for the memes, don't be surprised or don't be offended if it's not politically correct. Okay, so let's get started first with the concept of recipe. So does anyone would like to describe from his point of view how he how he would describe a recipe, like a cooking recipe? Anyone has maybe an idea? Yeah, Stephen.
It's a set of ingredients and then instructions on how to combine those.
Okay, yeah, so here there were 2 main keywords. There were like ingredients, and there were a set of instruction. So that's literally how it is. A recipe, if you look at the formal definition on the dictionary, is a set of instruction on how to cook something, and you use ingredients. So basically, we can think of it as we start with basic elements, and we use a step-by-step process to then arrive to an end goal, to a dish. So it's literally a tutorial. It's how to make, for instance, spaghetti carbonara. And you can think of it also from the starting point as a process of what with these ingredients, what you can do with them. So basically, with the same set of ingredients, you can arrive to different dishes with different steps and different processes. So let's just make it really Eli 5, really. Here you can see there are 5 ingredients on the screen. And with these 5 ingredients, with the whole process, we can arrive to 4 different dishes. Here you have 1, very healthy. Then you have a second one, a bit more popular probably in Mexico, I guess. Then you have a third example. This is a bit more fancy. Or then you can have like even more different ideas, where instead of having potatoes as being something you will eat, you will have a potato as a container. So basically, you can see that with the same set of ingredients, you can arrive to different outcomes. So 5 ingredients for 4 possibilities. For those interested, the recipes are on this link below. Okay, so at this stage of the audience, I've never actually presented this slide. I'm wondering, there's either one side of the audience who is wondering what are we even talking about? Hoping that we're going to talk about LSPs and standards. And because this is a recipe presentation, I had to put Gordon Ramsay on the slide. It's a must. I had to do it. So yeah, so we're not going to learn how to make a 30-minute meal in this presentation. We're going to now move on to how we can describe recipes from the programming point of view. So recipes, does anyone know these books already? Everyone here? Yeah? Okay, so like these books, any developer loves them because they look like a bit collectibles, really. But yeah, this concept of recipes and cookbook, it's quite popular in computer science. Cookbooks are basically standardized instruction on how to achieve a certain task. And in these cookbooks, you will find basically a set of code snippets that you assemble them together, and if you follow the step, you will arrive to the end goal. For instance, how you can, using a regular expression, how you can validate the format of a credit card number or an email address to validate this. So recipes are just self-contained solutions, and there are generic ways to do certain things. And you can assemble the elements in different ways, and you have a different stack, for instance. Everyone is familiar to things like the min stacks or the lam stacks. So these are just basically modules that you can look at, see as ingredients, and if you assemble them together, they lead to specific applications. And then you can expand on the solution you can personalize, and these really help to bootstrap you to get started. And the recipes also help you to pick the right stacks for the right use case. So for things like basically what backend framework you can use or front-end framework, and you can then focus on actual development and not fall into this trap where you have to figure out everything. These are not real books, by the way. They are just a parody. Don't try to buy them online. You will not find them. OK, so now we have seen recipes as in programming. Let's narrow it down a bit further. Why a recipe is actually very relevant to the concept of the blockchain, the technology. It's very simple. The only reason why it's really relevant is because blockchain, the technology itself, is a recipe. It's basically a set of technologies that have been assembled together in a very specific manner. And this makes the blockchain as a technology something very innovative. And if you really look at the whole background of this technology, blockchain is built on cryptographic primitives. And all these technologies existed. For instance, public key cryptography. Back in the days, this was something like, it was a very big deal. And if you had things like hashing functions, digital signatures, then you had predecessor to this technology. So all the time, blockchain is really built upon a huge series of technology. Like here in blue, it's everything around digital timestamping. And this, and then here we have like a peer-to-peer network, which led to Bitcoin and the first software implementation of the blockchain. So the predecessors of cryptocurrency and the blockchain really used the same cryptographic primitives. But these primitives were assembled in a particular way which didn't make it as successful. For example, David Shom with DigiCash had an issue with his cryptocurrency relied on a very centralized server and a patent. There was not so much element of a network. There was not really a network effect. There was no merchant and there was no client. So there was not really this network effect. Or Weidai with B-Money, it was a bit lacking of the consensus algorithm power. It was not really figured out how people in the network can reach consensus. And Bitcoin, in comparison, if you want to look at blockchain as a recipe, there is only one place where it's really easy to figure that out. It's the white paper. the abstract of the paper describes all the ingredients. Literally, the ingredients are things like all displayed in this abstract. If we read the sentences, we can see things like digital signature provide part of a solution, but the benefits are lost if the trusted third party is still required to prevent double spend. And then the solution provided is here, the network timestamps transaction by hashing them into an ongoing chain of hash-based proof of work. All the elements here are described in the white paper. So we can see that blockchain is the assembling of all these components and primitives in a very specific way. Oh, okay. So now that we looked at really why the idea of recipe is relevant to the blockchain, let's now read down to LUKSO and to the LSPs. LSPs really are basic building blocks. They are smart contract standards, and that, as you have seen from the previous presentation, they enable to build really a really different type of solution. For instance, universal profile use a set of standards. And we can start just simple by building basic recipes, just for instance with metadata. So metadata is anything around the LSP2 standard. So LSP2 define fields like the key type and the value content. So these help to define how we are going to store the data and how, for the user, we are going to represent this data and interpret it. And with just these basic fields, we can create things like a standardized way of storing information. A universal profile stored all of its assets under the LSP5 receive assets. And Vault, in the same way, stored all the assets that the Vault own under the same data key. And we have just assembled here two elements to define this for every smart contract. All the smart contracts use the same combination, the same recipe. So each key type is good for a different purpose. An array for the list. Here, a mapping is for retrieving specific information for a specific address. And mapping with grouping with it's useful for subcategories. And if we look at that from like really an example of a practical use case, we can use a recipe like arrays of key types to store the server on a social platform that the UP is connected to. So here, for instance, we could have a UP that use this kind of metadata to store the list of the server that it's connected to. So this is a practical example how we can use these metadata. Then we can assemble even more differently. We can let's use the type mapping. Mapping, we can use that to assign a specific information. For instance, here, an example would be the token that you want to allow your profile to receive. So if you want to whitelist specific token, you can use a metadata schema like that. And Boolean just specify if you are allowed it or not. And you can expand on that. You can build use cases that are actually common to the real world. You can do things like a blacklisting token, or you can do things like blacklisting senders, something that is quite common in Web3, because there are a lot of spam tokens out there, and also you don't want to receive funds from, for instance, for addresses that have been blacklisted. Here this is an example of an address that was involved in the polynetwork exploit, a very large hack in Web3. And you obviously don't want your P to have anything to do with this address. So using this concept, you can build basically these kind of firewalls for smart contracts. Let's look at another one of a metadata recipe. One that I particularly like, which is a bit array, which is a very efficient way to store attributes for instance, for an item. So it's always easier to think of it from the use case perspective and then work backwards. Here, let's imagine we have a jacket which is digital, and we want to specify the attributes of this jacket. We can say this jacket is waterproof, windbreaker, and has also a warranty attached to it if anything happens. And you can just simply use the binary representation of a value and any bit set under the hood. So here OXOD in binary will be 1101. Any bit set will represent the attribute of the jacket that it contains. Okay, so now let's move towards a more practical example with LSP1. So we started with metadata, which is more narrow. It's just the storage of a contract. Let's now combine that with LSP1 to build some basic boilerplate. So with LSP1, I think you have seen from the previous presentation from Stephen or from Johan, you can build a lot of use case that are relevant to the real world. You can do things like a financial application. If you have a bank account, a bank card, you're probably familiar with things like save a change or creating a bot to put some money aside when you receive it, or automate payments, billing. And you can also use things like firewall preventions or news subscription. And news subscription is a good example. So I'm just going to move to VS Code because the slides are doesn't display properly. But this is a basic. Yeah. Yeah. Can everyone see? Yeah, here. Yeah. Okay, great. Thanks. Yeah, so this is how you can really just use LSP1 as a basic example to create a new subscription. So the idea is that the type ID here can be a unique identifier for a specific news topic. So you have the company that deploys this contract, controls it, and then triggers it to emit an event on the network with a specific type ID when new news have been published about a specific topic. So let's look at that a bit more from with some illustration. So this is the flow. The company, you have a news company, you deploy this contract, you control it, and the company publish articles for a specific topic. The topic are we cannot really see here, but they are things like business news, fashions, and every time the company wants to notify the users, it just calls this contract the universal receiver function. And users, on the other hand, have through their application an event listener. They just register the topics they are interested in. So let's say, for instance, I am interested into things like food, politics, science, and technology, and football. I list all these topics under this data key, and the front end of the application, of the app, listen for the universal receiver, and it's just going to filter with the type IDs that I've listed. The type IDs are what I'm interested in. Okay, so now let's move with another example. How do you prevent spam token from being sent to your address? This is something that everyone I've noticed in the LUKSO community talks about. And this is actually quite relevant because this is, for instance, a screenshot of my wallet. I have like something like 50 spam token. I've never asked for it. And this is insane. That doesn't make any sense. Like, if I want to get rid of them, I interact with a contract, and what happened? I probably going to be wrecked, and I lose all my assets in my wallet. And the reason is that these smart contracts are spam, and they are just social engineering that are built to make you think that you're going to claim something, you're going to be able to redeem, but in fact you're just granting access to all your token, and you're going to lose everything. So how can we prevent that just in the first place, from either receive it beforehand? Well, we can use LSP1. So I'm going to move again to VS Code here with the example. So the way we can do that is that we can have the same model as the blacklist registry. We can have a model of a blacklist registry like the same way we have in the internet with blacklisted IP addresses. But instead of blacklisting IP addresses, we blacklist tokens, token contracts. So an organization can deploy this contract, register the spam token under it, and you can see here it uses the LSP2 standards, the metadata. We have libraries, smart contract libraries for that to generate all these mapping keys. And basically, my universal profile is going to attach for the specific type ID when receiving tokens this universal receiver delegate. And every time that I'm going to receive, someone is going to try to spam me by sending me spam tokens, this universal receiver delegate is going to run. And it's going to do the following. The first step is going to do like the same way as you will define on the recipe. You will say first step is going to generate the mapping key for this token address. Then we're going to retrieve the value under the storage. And if the value is set to 1, that means that if it's a Boolean, that means that this token is blacklisted. And if this token is blacklisted, we just revert. We prevent completely the transfer from occurring. So this is the idea of how organizations and you can build products or protocols like that. You can have this system. So the user, and this is a very decentralized way of doing it, because you can have multiple registries deployed and you can register and unregister at your own will. And yeah, and this is basically how you can prevent this. This is how you can have a boilerplate to build that. Okay, so let's move to the last part of the presentation with a more advanced combination, as you can see from the picture, where there are more things going on, more standards and more elements combined together. So it was really interesting in the previous presentation. You have noticed that Callum was displaying how the UP can be used to do multiple use cases. And technically, a universal profile on its own can be used for even more application. You can, because it has all the basic elements for making it very flexible and applicable to different type of applications. It is in its own recipe because it has all these standards. And one way we can use it, for instance, is as an entity for like a brand. You can have a brand with permissions, with different users, employees that have different permissions, where, for instance, the founders have full access to the profile. And you can have the company can hire a product manager that is going to be restricted to set data on the NFT collection that this brand is creating. And you can have another employee which is basically a treasury manager, and this manager has the permission to super transfer value, and it can basically manage the funds of the company. So it can transfer funds of the organization. And you can have flows like as follows, where you have the founders that create the NFT collection. And then, because the founders are too busy with other things, they set the permission for this marketing and design manager. And the design manager is allowed to interact with this contract. It's listed under its allowed addresses. And he can then make transactions through the key manager. It's actually through the UP, because we have built LSP20 with it to make transaction easier. And the design manager is going to interact with the UP. The key manager will verify its permission, and then it will allow him to set data. So you can have all these permission systems to build this kind of proof of concept. Okay, let's look now at another example. And here we are using LSP8 and LSP25 together. So LSP8 is the NFT. It can be used to represent an NFT. And here we can use it to create voting units. So each NFT in the contract represents the voting unit for a specific user. And you can recreate an election-like system where users meet the NFT for themselves. So the NFT represents the ballot. And then they can submit their vote by transferring the NFT to the candidate, to its address. And the number of votes that the candidate has received is basically the balance of its address. So it's the total number of NFT that it has received. But you can add a bit more to it. You can add things like LSP25. And this way, LSP25 is the execute relay call standard. It's the standard behind the gasless transaction. You can use that to separate the submitting of a vote to the signing. Why? Because if you are a user, you are going to transfer to cast your vote, you're going to have to interact with a contract, you're going to have to pay the gas. But if you have LSP25 built in, a user can sign the vote by sending the execute relay call, and it can do a system where it can give a transaction to someone that it trusts, for instance, a family member. Like if you are in another country and you want to vote at your election, you can ask a family member to vote on your behalf, and you can do something similar. And then this person that you trust, so for instance my sister, can submit the vote, can basically submit the vote. Or the service, the organization, can gather all the vote and cast all of them at once with execute relay call. So yeah, it's either you vote directly or you can ask someone else to submit the vote. And the way we can, if you look at the code, the way it works is that you deploy the contract specifying the period here into the constructor of when the election is going to take place, when it starts and when it ends. The user is going to retrieve its vote, it's going to emit it for itself. And then the user can sign the transaction of chain and gives the transaction to someone else, and this other person can submit it on its behalf. And the way it works is literally the same way as you will describe a recipe. The first step so we can describe it like that. In order to submit a vote without paying the gas, I have to do the following. The first step is that I have to retrieve the address of a voter from the signature using LSP25. Then I have to validate its nonce. And then step 2 is I have to validate its nonce. Then step 2, I have to increase its nonce. And the third step is I have to extract all the parameters from the transaction that I've signed to get the vote ID and the candidate that I'm voting for. Then the fourth step is that we have to validate that this vote ID is the vote ID assigned to the voter. And finally, we can cast the vote by transferring this NFT, vote ID, to the candidate. And then we just return by saying that we have casted the vote successfully. So we just do the internal transfer here, where we send the NFT to the candidate, and it's the balance of the candidate, it's all the vote that he received. And we can have also execute relay call batch, where the organization can, the election, the services responsible for running the election can gather all these votes and submit everything in the whole batch, all at once. So here we're not going to solve all the problem. Things like how do you prevent manipulation of the election, or how do you assign voting right to the right person, but this is a good recipe that can be used as a good basis to really then kickstart your project and then expand upon it. Because the smart contract counts the vote automatically, the voting is fully transparent, you can see all the transactions on chain, and you have the delegating available. But yeah, it doesn't solve everything. For instance, if there's some of the candidates that you don't want to vote for, that's unfortunate. You have no solution for that. Okay, the last example of advanced recipes is LSP8 collection of LSP7. So this sounds quite like complex, but it's actually, if you look at it from a real-world perspective, it's something probably that everyone has encountered. So what we can do is that we create an LSP8 collection to represent the product line, and each NFT is actually a smart contract. It's a token. Each NFT is another token contract. And the token contract is basically a limited edition of an item with a limited quantity available. So when you look at that, you might think, okay, what does all of that mean? But if you look at that, it's a bit more understandable. For instance, imagine a watch company. We're going to call it Time Chip. And this company creates physical watches, and it's a digital connection. There are an NFC chip connected to the NFT, and this NFC chip is embedded into the watch. Every time that the company creates a new series, it's going to create an LSP7 contract that is non-divisible. It's going to limit the supply, and you're going to be able to basically then have a limited quantity of each of the watch. And so you can create series where one series is scarce and one series is more common. For instance, here the classic series, there is only 3,000 items, and the black series there is and the gold series there are more items. So each NFT, each token ID points to another contract. And finally, you can then use LSP4, which is embedded into LSP7, to basically assign some attributes. For instance, the watch, you can set the metal, you can say if it's a limited series, if it was water resistant, etc., etc. Okay, so let's clean up the kitchen, and how can we conclude on all of that? So LSPs and look for concept or recipes, we have to understand that these are not complete implementation ready to use. They are basically code samples and tutorials or boilerplates that help you to kickstart to build your application and to perform a specific task. They give you all the features that you need, so you can pick each standard for specific purpose. For instance, if you want secure ownership management, you can use LSP14. If you want meta transaction, you can pick LSP25. If you want multiple user to have access control, you can use LSP6. So each LSPs for specific features and use case. And a good LSP recipe is how you combine the standards together, how you combine them in a specific way, but not which standard you are picking. So as we were explaining in the previous slide with the Bitcoin and the blockchain, what makes the blockchain innovative, it's how the components and the elements are assembled together. It's not the actual elements themselves. And yeah, and if you want to learn more about each standards and how you can build on LUKSO, the best place to go is to go into the dr.luxo.tech, You can look at the standards and tools section in particular, so for building your application. And you can go also into the contract section where you will see the whole ABI technical reference and how each standard can be used for which purpose. And also what I'm really suggesting is anyone here who is a developer who is really looking to build on LUKSO, would really like to encourage you to submit issue or feature requests on our GitHub. If you are looking for specific things on how to do something, how to use standards or how to use a contract, please feel free to go to the drlukso.tech GitHub and to open an issue. And yeah, that concludes the presentation. And hope you like it. And if you have any question, I'm more than happy to answer anything. Thank you.